Okay, I'm Morgan Hite, and I'm in unceded Wet'suwet'en territory here in Smithers, BC. Let me just do a screen share for you. Okay, and we'll move over here, and you should see my title slide. Let's go full screen on that. There we go. So I'm going to be talking today about creating shaded relief with this technique called Skymodels, which you may not be familiar with. It produces this wonderful, intense looking landscape, which I think Sheng would really enjoy in one of her fantasy maps. And I've really started to like this, so I'm going to just explain how it works. Let's look at a few different algorithms for creating shaded relief for your map. So this is a piece of topography in British Columbia near Kitimat, and I've made 6 different pieces of shaded relief. So in the top row we can see Blender, which is the open source computer animation software. The middle image is GDAL, which is what I'd call the common hill shading algorithm that's used in both QGIS and ArcGIS when you just ask for a hill shade. It's got a single sun, you give the azimuth of the sun and its elevation, and you get this kind of image. On the upper right is the same algorithm, but using the combined shading, and this produces something like what we see in Google Terrain. It's a little shinier and more rounded. In the lower left, we've got the multi-directional light sources, so there are actually 4 light sources there. The bottom center is Skymodels. That's what we're going to be talking about today, and you can see how it's really quite different from the rest. And the lower right is Texture Terrain Shader, which is a form of processing on a DEM that allows you to pick out the ridge lines and the valley bottoms. So let's just focus on Skymodels for now. What is a Skymodel? So as I said, in a typical shaded relief, you are asked to place the sun in one place, but in reality we have an atmosphere that scatters light. So Skymodels are a way that we look at this dome of the sky and say light is coming from many different places, but in different intensities. It starts with a paper that Pat Kennelly and James Stewart published in 2014, and then a piece of software that James Stewart wrote called Skylum. And Skylum produces these outputs you see on the right here. The upper one gives you the overcast sky, so the red dots show where the most intense light is coming from, with the cooler yellow and then blue dots showing parts of the sky that are not so illuminating. And you can contrast that with the image below it, which is what they call the type 13 sky, standard clear sky, polluted atmosphere, where most of the light is coming from this one point where the sun is, but there's still light coming from other adjacent places, even all the way around the back of the sky dome. So we're going to use Skylum to create a sky model, and then we're going to use something called Raster chunk processing. So this is a great little Python program written by Jake Adams in Utah, and it takes an illumination file from Skylum, and then you feed it a DEM, and it chops your huge DEM up into tiles of manageable size. It renders a hill shade for each one, and then it stitches them back together. Here are some resources if you want to try this yourself. So on the top we have Jake's GitHub page. That's where you'll download the raster chunk processing software and Skylum. Then we have Jake's 3-part blog post about how to install it and use it under Windows. And last of all, we have my blog post about how to do the same under Ubuntu Linux. As far as I know, no one's running this on a Mac yet, but I think it's merely a question of someone who's a Mac user and a pretty good Python programmer to just get the pieces and figure out how to make them work. I'm sure this should work. So it's a 2-step process. We'll start by running Skylum and making an illumination file. The illumination file is just a CSV file. There's an example in the upper right there. It's just a series of coordinates in the sky and how much light is coming from each one. And Kennelly and Stewart looked at 20 different sky models that are standardized by this thing called the International Commission on Illumination, which I didn't know that existed, but there you go. So some of them are what you'd expect, the overcast sky, the clear sky, and so on. And others are what they've numbered as the different types. So we have like the type 15, white-blue turbid sky with broad solar corona, or the type 4, the overcast, moderately graded, and slightly brightening towards the sun sky. So you get to choose from all of these. And then in part 2, once we've got that little CSV file that tells us where light's coming from, we'll feed a DEM into raster chunk processing and let it work on it. And as I said here in the slide, the big plus is that the DEM can be huge because it will chop it up into chunks. And so in effect, you're substituting time for RAM. In other words, you could have a DEM that's almost too big for your computer to process, but raster chunk processing lets you work with it. So I will just pop out of full screen mode here for a second and bring up Skylum. So on Linux, I run this under Wine, which is a Windows emulator, and it works great. And under Windows, it works quite well. So it opens with this little sky dome, and I can use my left mouse button to move it around. And I can use the middle mouse button to zoom if I need to. The sun, if you look at the status line at the very bottom, the sun starts with a 45-degree elevation, and it's in the south at azimuth 180. So I'll use my arrow keys to bring the sun around to the northwest, 315, because we normally like our light to come from the north or northwest when we're doing a shaded relief. So there we go. And then I'll right-click it to get a list of the sky models. So I'm looking at 20 different options here. Let's try the, let's see, type 8, partly cloudy, no gradation towards the zenith, distinct solar corona. That sounds good. And then I'll hit the letter P, and it will generate the model with the points. So I can see that this is going to be chiefly light coming from the sun direction, some scattering. And I may say, this is good, but I want to raise my sun a little bit. So I take my sun up to 50 degrees, recalculate that model. Okay, this looks good. So when I have something that I like, I'll hit O, and it will prompt me for a file to write this out to. I'll call this the, what was it, the type 8, sun at 50, elevation 315 azimuth. I'll give it a CSV extension, and it writes it out, and then I can quit right out of Skylum. It is important, after Skylum writes your illumination file, here I'm opening it in a simple text processor, to delete these top 7 lines, because raster chunk processing doesn't want to see this header information. It just wants to see the comma-separated values. So delete those top 7 lines, save and close, and you're in business. Okay, so how do we prep the DEM? It's the same prep as you would typically use if you were doing hill shading in QGIS or ArcGIS. It needs to be reprojected into a metric projection. It could be UTM or Lambert with square cells measured in meters, like it's a 20-meter DEM or a 50-meter DEM or 200 meters. It can be huge. I've run DEMs up to 2.8 gigabytes, almost 30,000 pixels on a side, and raster chunk processing handles those quite gracefully. And it's good to just put your DEM and your illumination CSV file in the same directory as the raster chunk processing program, which is usually called RCP master after you have installed it. This is what it will look like. So we're going to use the command line. I know this is very scary, but it's actually not going to be scary. There's no horror here. There's a general form for the command line at the top, but we'll just look at our case, the second line. So I'm going to have Python 3, which invokes the Python compiler or interpreter, raster chunk processing.py, which is the program, and then there are a series of parameters that I pass with different letters. So there's the M parameter, Skymodel. I have to specify that because raster chunk processing can do many different things. It can do a Gaussian blur on your image or something like that. So we have to tell it we're interested in the Skymodel. The S parameter tells it how large a tile to use. So I've got 4,000 by 4,000 pixel tiles. The O parameter tells us what overlap to use. So if you think about it, if you have two adjacent tiles, you do want a mountain on the edge of one to cast a shadow onto the next one. So by having overlap, this allows for that. 200 is pretty generous. You can go as high as 600. The P parameter tells it how many of your processors to use. So I have 12 cores on this computer, so I'll use 10 of them. I don't want to use all 12 because that will completely monopolize the processor scene, and I won't be able to do anything else while it runs. The L parameter gives the name of the illumination file. I like adding this verbose flag just to keep me updated about how the process is going, because it could run for a couple hours. And finally, you have the file name for the input DEM and the output hillshade. Make sure that that file doesn't already exist, or it will throw an error at you. So you just type your command line in, hit enter, and it will spill out information about the illumination file, and then it will start processing chunks and telling you how that's going, as we see in the lower left. And you can go for coffee, or you can be kind of hypnotized and watch it play out. It's very fun. And after some time, out comes a geotef that you can drag into your favorite GIS program. Now, if you've done some hill shading in the past, you realize that I didn't mention vertical exaggeration, because typically we give the sun's azimuth, its elevation, and the vertical exaggeration on the DEM. So when Jake wrote this code, he just hard-coded it to always use 5 times vertical exaggeration, because that's what Kennelly and Stewart did in their paper. It's easy to change this. You just open the methods.py file in your text editor, go down to line 272 where it says in array star equals 5, and change that 5 to whatever vertical exaggeration you want. Save the file, and you're done. See, you're a hacker. And you know, this is the beauty of the open source things, that we can just go into the code and change the vertical exaggeration. So for the examples I've been using here, I've got this set to 2. A few final notes. You don't need to use the output of the Skymodel hillshade by itself. I actually like to combine a couple of these. So we've got the overcast Skymodel, and then the type 13 Skymodel, which is the clear sky polluted atmosphere. They seem to go together really well. And so I've made a combo of them there, which I do with 50% opacity on each one, and just put them at the bottom of my stack. And another interesting note is that Skymodels compute actual shadows. It came as a bit of a surprise to me that the standard hill shading algorithm, which relies on what they call Horn's slope algorithm, and is the one that GDAL uses, or ArcGIS, it doesn't actually calculate shadows. It looks at the aspect and slope of each piece of terrain. It looks at the incoming solar vector, and it decides how light that would be based on whether it's completely orthogonal to the sun or tilted away. So it computes a shadowed face, but it doesn't compute shadows. It never asks, is there a mountain in the way that this place could not even see the sun? But the Skymodel actually computes shadows. So I created this image at the bottom by making a Skymodel where all the light is just coming from one point in the sky. I just did this by hand in a text editor. And this is the Baltoro Glacier in Pakistan. It has some great, very high peaks on the north side, and you can see that shadows stretch across the glacier. So if you want shadows in your map, Skymodels is a good option.
1 minute.
Thanks. And this is my last slide. So I went through that without answering a lot of other previous questions. Where do you get your DEMs? How do you reproject them? How would I even make the basic hill shade in QGIS or add that shaded relief as a layer in my map? So if you aren't familiar with those things, you can hunt around on my blog, which is The Wandering Cartographer. I think I've written pieces about most of those. And yeah, other than that, that's a wrap. So yeah, any questions there, Shane?
Thanks, Morgan. So far, nothing's come in on the chat, but we're about 10 seconds behind everyone else. So maybe we'll give it a minute and wait and see.
Okay, let me come back out of screen share then.
Fantastic presentation, by the way. That's such a, it's very stark to see the difference between what I'm used to seeing, you know, producing your standard shaded relief models either in ArcGIS or QGIS, compared with those extra shadows add a layer of realism that really makes that terrain pop out. Rich Nelson sorry, go ahead.
No, I was going to say, it is really arresting what a, not necessarily gloomy, but sort of a gravitas feel that can give your map.
That's a lot more lively. Reg Nelson asks, you showed an image from Blender early on. Do you think that using an HDR image for illumination could give realistic shadows?
HDR image, not sure what that means, but Blender is another piece of software that does calculate shadows. So you can get very good shadows in Blender, and often in Blender you get good results by having multiple suns. So you might have a sun in the northwest and then a second but fainter one overhead, and that begins to approach what the Skymodel can do.
Xenon asks, hello, have you used your techniques on high-resolution LiDAR-derived urban DSM?
Yeah, no, I actually have never gotten my hands on any LiDAR, so I'm quite interested to do that, and I'd love to hear if somebody does.
You might need a few days of processing.
Yeah, you might. Although one thing to say in that context is, if you're producing a map for like a 300 dots per inch print process, the pixel dimensions of the DEM you use are pretty much determined then by the size of your map, right? Because you want one raster pixel per dot on the print. And unless the map is really huge, it doesn't make for a DEM that's going to be much bigger than the one I described using before, the one that was about 30,000 pixels on a side.
Any last minute questions? Zachary King asks, this seems like a perfect opportunity for a QGIS plugin.
Yep, that sounds good. Let's just get somebody who knows how to write that. Absolutely.
And Jeff Clark says, hey Morgan, thanks for the session. Can Skylum use colored illumination like Blender?
As far as I know, it cannot. Yeah, in Blender you can put a warm yellow sun in one place and kind of a cool blue sun on the opposite direction and get a really nice effect. As far as I know, Skylum can't do that, but I haven't really looked through the coding for raster chunk processing to see, you know, if there's any option there. It's a good idea.